All right. Obviously, Southeast Florida is no stranger to lighting problems. Um, we've all seen maps like this before. Boca Raton is located pretty much right in the heart of where the worst lighting is. We're at the southern end of Palm Beach County there by the red arrow. And you can see the development in our area. Boca Raton right here, we have this little dip in development, and as you move south towards Miami, obviously it gets a lot wider. So at night, it kind of mirrors the same thing as you'd expect. But we are in the situation where we got a little bit good here and quite a lot of not good there. Boca's a really unusual city, especially for Southeast Florida. I've got 5 miles of beach. Last year, or this year actually, I had about 1,200 nests in that 5 mile area. Oppose that to the Panhandle, 250 miles, I think, and roughly 900 nests. The interesting thing about Boca is being an urban area, of that 5 miles, there are more than half of it is park areas. And the park areas have no beachfront lighting whatsoever, with the exception of Spanish River Park, which did have street lights that were visible from the beach. They were taken out in 2001 in place of embedded roadway lighting, LEDs in the pavement itself. One of these areas, South Beach Park, looks like this at night. Beach is nice and dark, really great. Dune is low and flat, and the city behind it is really bright. Turtles, nesting females, hatchlings, they take their cues looking for the lightest horizon, which generally is reflection of any kind of light off the ocean, versus the darkest background. So you want that dark dune, but if it's really low and mom's coming out of the water and sees this, she says, there's a lot of light up there. There must be water. I don't want to lay eggs there. And they'll avoid that area. A story that started quite a while ago, actually since 2001, we've been GPSing every crawl in Boca Raton. And this is the South Beach Park area between the blue lines. And you can see this is crawl densities from ArcGIS. So the red indicates more crawls. And you can see that there's just this one spot right in that same area. And then 2006, it just completely disappeared. That gave us some pretty good clues as to what was going on in this area. When we looked at that area, we found that the rest of the dune, low and flat, except for right there, 3 Australian pine trees, about 80 feet high, which is about 50 feet above the dune itself. And that's where that area of crawl activity was. So as scientists, we wanted to go out and do something to find out if those trees really were the problem. So we had a hurricane come through, and the hurricane took out 2 of those trees entirely. They were cut down, and 1 tree was left severely damaged. So we believe loss of those trees, 2005, at the end of the nesting season, was responsible for that loss of the crawl activity in that area. Must be the trees themselves were shading the beach, making it more attractive to the female turtles. Well, if that was the case, we would expect the condominiums, if they're dark, which they are in Boca Raton, to be attractive to the turtles. And indeed, changing out the densities a little bit, turtles do 2 things when they come out of the water. They lay eggs or they don't lay eggs. And normally we expect to see 1 laying eggs for every 1 that doesn't lay eggs. So we see that 1-to-1 ratio. The red are those not laying eggs, or what we call false crawls, and the green are nests. And when you look at the building footprints right there, the taller and wider the condominiums are, the more green you get in front of them. And just compared to South Beach, that's what we're getting in a natural park area now. So the turtles are actually moving out of our natural areas into our more unnatural areas because there's more shade from the sky glow. We also look for disorientations from the hatchlings. And this is what we like to see. This is what we should see. Here's an egg chamber, and there's about 100 hatchling tracks running into the water. Every nest has roughly 100 eggs in it, so we expect to see something close to more than 80 hatchling tracks come out of it. See how straight they go? Right in, narrow cone. Sky glow disorientation's a little bit different. Here's the egg chamber, and you can see they've come out in every direction possible. We call it a bomb burst. And in that situation, the hatchlings are just wandering everywhere. They cannot find a light horizon. They cannot find a dark horizon. They have no clue where they are because the light's all around them. And this is the nest that disorientation occurred at in South Beach Park. And again, that kind of low sea grape dune. And that's a look at the park area in the daytime, pretty much after Tropical Storm Sandy pulled through. So there's been a little bit more activity on the beach than we normally see. And this is that area. That's the South Beach area right here. And we have that condo area right there. So it's two areas very close to each other. The total nests in that area, that zone F, as we'll put it, you can see has been on a decline. These 2 years we had renourishment projects, so that's why those red arrows are there. Renourishment is just pumping sand up from the bottom of the ocean, putting it on the beach. Beach goes from being 50 feet wide to 200 feet wide. So there's a change there. When we looked at the beach width, it was as we expected. Renourish it, beach gets wider. And you can see here, we went from what normally used to be a 50-foot wide beach to now kind of a little bit more than a 100-foot wide beach. And then when you look at the number of false crawls divided by the number of nests, remember I said that ratio should be 1. We expect to see 1 to 1. And indeed, pretty close early years, renourish the beach, and you pretty much double it. So mom's not happy there. Something's going on with the beach width increasing. And that's just both of those maps, or both of those graphs together. I multiplied the false crawl nest ratio by 50 just to get them close. And you can see there's quite a bit of correlation there. And when we look at the false crawl to nest ratio versus the beach width, you get a really nice correlation. And those engineers in the audience may expect to see more. This is biology. This is really good correlation to a biologist. And that's the percent of disoriented nests. And you can see park area, not so many nests being disoriented until we renourish, and then it shoots right up. Wide beach. And remember, this area has no beachfront lighting. And again, we get a fairly good correlation, not quite as good. The big difference here is that mom averages about 300 pounds. Pretty easy to see her results in the morning. We don't miss them. It can rain, and we still know mom's been there. Hatchling, 2 ounces, about yay big. Little bit of rain, no tracks. Any wind, no tracks. So they're a little bit harder to keep track of. So for hatchlings, that's a really good correlation. And combine them up with the zone next to it, and it still stays in that trend. This is our north area, Spanish River Park. I mentioned it did have street lights up there, so we eliminated those years. And this is our total nests, and again, a decline up until 2010. Everything started going back up, which is good. That's a different story entirely. The beach width, renourishment here, and over at the other red arrow, obviously beach width up, slowly declines. False crawl nest ratio, again, renourish. Turtles don't like that area. That's a renourishment artifact. That's not necessarily the beach width. And in this area, interestingly, that's no correlation, even to a biologist. Pretty flat line. The big difference between this area and South Beach is the dune heights are quite different. So this park predominantly had Australian pines in it, which averaged about 80 feet high. So the whole profile of the dune behind the hatchlings in this area is very different than it is in South Beach. And there's the Australian pines versus the dune as it would be in South Beach. Disoriented nests, again, the percentage of disoriented nests goes up when you renourish. And the hatchlings respond as they did in South Beach. Seems that the hatchlings are messed up regardless of the dune. And this is just a study showing kind of why the width is going to be important with sky glow effects. A friend of mine went out and just looked at how far turtles went from the water. And normally beach is 50 feet wide. Loggerheads averaged about 40 feet from the water. Greens about 60 feet. So if you widen it to 200 feet, they're still going to be 40 feet from the water, which means they're out there a lot further, which may explain why this has such an effect. And obviously, the thing I think anyway is the beach site must have the same dune height conditions over the period of the study, which South Beach did, regardless of the hurricanes. Spanish River, not so much. Australian pine trees are more susceptible to hurricanes. Beach width in the unlit park areas does correlate with a higher false crawl to nest ratio. And beach width in unlit park areas correlates with a higher percentage of hatchling disorientations. And the only lighting in these areas possible is sky glow. And both adult nesting female sea turtles and their hatchlings are negatively impacted by the sky glow. I've recently purchased a hypsometer. My big interest now is to go out and start correlating dune heights with beach width and everything else to see if we can explain why we get the flat lines versus the nice correlations. We have those condo areas to compare. Remember, the condos are dark too. And that's what we're going to be looking for, considering the changes in dune vegetation as well. And obviously, that's the message we try to get across to everybody in Florida. The problem really is something that we have to fix inland. This isn't a beachfront lighting issue. And it's something that Floridians are slowly warming up to. You saw what Scott showed about the real Florida, and God knows he's pretty much right. But they're beginning to kind of crawl out of the hole and realize it. Another project we're working with we do have some of the SQM monitors, sky glow quality data loggers, and we have them up in various areas. One is up in Spanish River Park. And what we're finding interesting, this is just one night, and you can see it's relatively dark, and then all of a sudden it goes wonky. This candelas per meter square, clouds going overhead. So hopefully that'll help us correlate. Some days we'll go out and survey the beach. and we'll find 20 or 30 nests disoriented all over the place. Go out the next day, nothing. So we're suspecting, yeah, the rainy night. Unfortunately, when the night is rainy, that's when it's harder to find the hatchlings. So this may help us nail things down a little bit more. And that is it. Thank you very much.